which function is represented by the graph. This right here is a exponential function. And what we could do is we could just take random points and plug it in. So let's start off with this point right here. We know that's going to be 1, 2. That should match up with our graph. Then we have another point right here, which is, I believe that's 2, 0. Looks pretty close to that. We have any other order pairs we can plug in. Maybe this right here, which is 3, -6. Okay, so we're thinking about plugging in those points right there and see which if it works with everything. So let's start off with 1, 2. So for this, it'll be -3 to the first power and then +3. And we're going to see what we get out. So again, we're plugging in 1, right? Now, because we don't have parentheses around this -3, we're only taking 3 to the first power, and then we're attaching the negative. So 3 to the first power is 3. Then you attach the negative, you get -3. -3 plus 3 is 0. Not +2. So it's not going to be the first answer. We already know that. Second one, plug in 1 for x right there. So we have negative. Take 1/3 to the first power. That is 1/3. And then +3. Negative 1/3 plus 3 is not going to give us 2. So answer is not going to be B. Let's check C. Here we have -3. And then we're going to plug 1 in for x. Now right now in the parentheses it says x to the -1 power. Or I'm sorry, x. It says the exponent is x minus 1 power. So if we plug in 1, it's going to be 1 minus 1 for our exponent, and then +3. Remember, we're plugging in 1 for x. 1 minus 1 is 0. So what is, if you have -3 to the 0 power +3, what is 3 to the 0 power? That's going to be 1. Then you attach your negative, and it's -1 plus 3, which is +2. So far, I think that C might work. Now, it might also work for D, so we need to double check that. And if it works for D as well, we need to check other order pairs. So for this one, we're going to plug in 1 for x. We get negative. Then you have 1/3. Plug in 1 for x. That'd be 1 minus 1 and +3. 1 minus 1 is 0, so it's -1/3 to the 0 power +3. 1/3 to the 0 power is 1. And attach the negative in front, so now it's going to be -1 plus 3, which is +2. So both C and D, they both work for 1, 2. Now we're going to check the next order pair, 2, 0. And we've got to check it for C and D. So we plug in 2. First, we're going to do C right now. -3 to the 2 minus 1 power, and then +3. 2 minus 1 is 1. So you got -3 to the first power +3. Then you got to take 3 to the first power, which is 3. And then attach your negative. It'd be -3. And that's going to give us 0, which does work for 2, 0. Okay, so let's check D. We plug in 2 for x. It'd be -1/3. And then it'd be to the 2 minus 1 power +3. 2 minus 1 is 1, so now we have -1/3 to the first power +3. 1/3 to the first power is 1/3. So now we're going to have -1/3 and then +3, which does that give us 0 right here? And I don't think it does. So C is our answer. Now let's talk about another way we could have gotten that as an answer. First off, the +3 here means the graph is shifted up 3. Notice how the has a horizontal asymptote right there at +3. So it's shifted up 3. Second, this negative in front of the 3 means it is reflected. So instead of going, up like this or down like this, it's reflected. Okay, and then the other thing is, not only is it reflected, but if I were to reflect this back, it would look like this, which means it's growth, which means the number in parentheses, or the number that's being taken to a certain power needs to be bigger than 1. Notice this number here, the 3, is bigger than 1. And then the other thing is that the x minus 1 means it's just shifted to the right 1. But that's, if those rules, if you're not sure about those rules and how they work, you could always just take, ordered pairs and plug them in like we just did.